I doubt if any student remembers this solution. Let's get started. The question says, if 2q3 base 5, first statement, equals 77 base 8, second statement, find q. At this point, you would agree with me that we are having this in base 5 and this other number in base 8. But of course, we want to ensure both of them have the same base. And for this to take place, we need to convert them to the common base, which is base 10. So let's get started. When you have a question like this and you have to convert to base 10, simply rewrite those values 2, q, and 3. Multiply by the base. Multiply by 5, multiply by 5, multiply by 5. And the next thing you want to do is add the power on the base, starting from 0, 1, 2. At this point, you want to bracket to avoid confusion. Bracket the values to avoid confusion. So this that we have done is just for the first case, which is 2q3 base 5. So let's equate it with the second expression, which is 7 in base 8. So multiply by 8, multiply by 8, power 0, power 1. And of course, we involve our brackets to avoid confusion. So with this, we can simply proceed. So looking at this first expression right here, 5 power 2 simply means 5 times 5, which is 25. A lot of students mix it up and they write 5 times 2, 10, which is very wrong. So now we know it is 25. So we simply write 2 times 25. The next expression is 5 power 1, and any value raised to power 1 remains that same value. So that's plus q times 5. The next value right there is 5 power 0, which is 1, because any number raised to power 0 is 1. So we have plus 3 times 1. Likewise, on the right side, 8 power 1, would you guess that? 8, that's good. So we have that to be 7 times 8 plus, what's 8 raised to power 0? That's very cheap. What's that? 1, of course, yes, you're correct. So we have 7 times 1. So at this point, we need to multiply each entity. 2 multiplied by 25 is 50. So we have 50 right here. And q multiplied by 5 is 5q. 5q right there. Plus 3 multiplied by 1 is 3. Equals 7 multiplied by 8 is, tell me, what's that? 56, of course. Plus 7 multiplied by 1, you agree that is 7. And do not forget, we need to collect like terms. Collecting of like terms simply means that all digital values goes to the right side and all values in algebra form remain on the left side. So plus 3 would be collected on the right side and plus 50 would also be collected on the right side. So you agree with me that we are left with positive 5q, which is the same as ordinary 5q. So on the right side, we have 56 plus 7. And do not forget that this positive 3 goes to the right side and becomes negative 3. And positive 50 goes to the right side as well and becomes negative 50. So we have negative 3, then negative 50. So let's do a simple sum from 56 down to negative 50. So 56 plus 7 would give us 63. Then minus 3 would give us 60. Then minus 50 would give us 10. So we have on the left 5q equals to 10. And you have to remember that 5q simply means 5 times q, which means 5 times what value would give 10. And of course, let's see, divide both sides by the coefficient of q, which is 5, and these cancel out, so we're left with q to be equals to 10. So that means the value for q in the equation is 2. So let's go check and figure out the right answer. And the right answer is glaring, option A. A similar question to that is right here. It says find R if 6R7 base 8 equals 511 base 9. And to go with this, we want to ensure that the base 8 right here is converted to base 10, and base 9 right here is also converted to base 10. So let's get started. So at this point here, we have 6R7. So quickly, 6R7 multiply by the base 8, multiply by the base, and input the value for your power starting from 0, 1, and 2. So keep your brackets around it, then add up to avoid confusion. Keep your brackets and add up. So what we have just done is only for this left hand side in base 8. Then we need to equate this such that we have this 511 base 9 converted to base 10 as well. So this means we are going to have equals 5, 1, and 1. So we multiply by the base, multiply by 9, multiply by 9, and multiply by 9. So power 0, power 1, power 2. Keep your brackets and add up. Keep your brackets, add up. Keep your brackets, add up. So quickly, let's see how to deal with this. Going back to this, 8 power 2 means 8 times 8, and that is 64. So let's see how to go about this. So we have 6 multiplied by 64 plus R multiplied by 8 power 1, still the same as 8. So R plus 7 multiplied by 8 power 0 is 1 equals 5 multiplied by 9 power 2 means 9 times 9, which is 81, plus 1 multiplied by 9 power 1 remains 9, because any number raised to power 1 remains that same number, and we have 9, plus 1 multiplied by 9 raised to power 0 is 1, because any number power 0 remains 1. So let's go solve this bracket. The first we have there is 6 multiplied by 64, and that is 384. R multiplied by 8 gives 8R, and 7 multiplied by 1 gives 7. To the right side, 5 multiplied by 81 gives 405. 1 multiplied by 9 gives 9, and 1 multiplied by 1 gives 1. So at this point, we need to ensure that all ordinary numbers move on to the right, so which implies that positive 7 goes to the right, becomes negative 7, and positive 384 is going to the right side to become negative 384. And that simply means we need to collect like terms. And rewriting that, we have 8r equals to 405 plus 9 plus 1 minus 7 minus 384. So let's go check this out. 405 plus 9 gives 414, then plus 1 gives 415, minus 7 gives 408, minus 384 gives 24. And we need to divide both sides by the coefficient of r, which is 8. So this cancel out, and 8 in 24 gives 3. So the value for r is 3. So let's go check our results from the options given. 3. And you would agree that is right here, option C.